Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Fire Ant by Mello Robinson, and here are the rules. Normal Sudoku rules apply, which means fill every row, column, and box with the digits 1 through 9 without repeats. We also have killer, where digits in killer cages, which are these cages here, do not repeat and sum to the total in the top left corner. So for example, these three digits add up to 19, these three digits add up to 6, these three digits add up to 24, and these two digits add up to 9. So an example here could be something like 3 and 6, because these two digits add up to 9. And that's how killer cages work. Remember, you cannot have repeats in killer cages in this puzzle. We also have Dutch whispers, where digits along an orange line, adjacent digits along an orange line, must have a difference of at least 4. So, for example, if this were, say, a 3, this would have to be a 7, an 8, or a 9 to maintain a difference of at least 4 between adjacent digits. And that's how Dutch whispers work. And finally, we have XV, where digits are separated by an X, sum to 10, and digits separated by a V, sum to 5. And I think all the X's are along the Dutch whisper lines. But if this were, say, a 3, this would have to be a 7, because these two digits must add up to 10. So it kind of works similar to killer cages. It's just that it's the X's separate two cells only. And so, and they always add up to 10. So again, if that were 3, this would have to be 7. For the V's, if this were 3, this would have to be a 2, because these two digits must add up to 5. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. So let's learn how to Sudoku. Okay. So the first thing that stands out to me is the three cell killer cage that adds up to 6 and the 3 cell killer cages that add up to 24. There's only one set for each of those 3 cell cages, and for the 3 cell that adds up to 6, it's only filled with 1, 2, or 3. For the 3 cell that adds up to 24, it can only be 7, 8, and 9. Because those are the only 3 unique digits that can ever add up to 24, because it's the max, right? 7 plus 8 plus 9 is the maximum of unique digits, and it also adds up to the value that we have. So therefore, it has to be the same. So this is 7, 8, 9. These are 1, 2, 3. These are 1, 2, 3. And these are 7, 8, 9. Now, along these Dutch whisper lines are only digits that add up to 10 with another digit. So I probably could have started there first, but that's actually very interesting. So the thing is, in this box here, and I'm gonna introduce a. It's not a. I keep forgetting the term for it. Anyways, it's basically something that we typically use to reference the boxes in Sudoku. And we usually reference these boxes in standard Western reading notation, which is from left to right and from top to bottom. So we number them in that order. And this would be, for example, this box would be box 1, this would be box 2. We'd have box 3 here. This would be box 4, 5, 6, 7, 8, and 9. So that's just that's it, convention that we use so that we can easily communicate with other Sudoku makers and Sudoku setters and Sudoku solvers, and Sudoku solvers. So that makes it easy for us to basically communicate which box we're talking about. So in boxes 2, 4, 6, and 8, we know that the Dutch whisper lines all have X's in between 2 of those their digits. So for those Dutch whisper lines, the only ones that could fulfill that criteria are 1, 9, 2, 8, and 3, 7. Because 4 and 6 are not 4 away from each other, and therefore cannot be on a Dutch whisper line adding up to 10. So, therefore, in boxes 2, 4, and 8, 2, 4, 6, and 8, we know that every digit on the Dutch whisper line must be from 1, 9, 2, 8, or 3, 7. Therefore, that leaves in the other cells 4, 5, and 6. Well, that's very helpful specifically in box 8 because we know, again, all the digits on a Dutch whisper line, on the Dutch whisper lines in boxes 2, 4, 6, and 8 have to be from 1, 2, 3, 7, 8, 9. So this is 7, 8, 9. These are 1, 2, 3, 7, 8, 9. And these are 1, 2, 3, 7, 8, 9. Well, the rest of the digits in that box must be 4, 5, and 6. But the only digit that can be next to a V, which adds up to 5, is 4, right? Because if you have 5 there, that only adds up with 0 to add up to 5, and that's not a normal Sudoku digit. And 6 requires a -1, which is also not a normal Sudoku digit. So this is 4, which makes this a 1. These are 5 and 6. This is only 7, 8, or 9, because it's next to an X with a 1, 2, or 3. Therefore, let's continue. Okay, this can't be 1. This is now required to be a 1 because one of those has to be a 1. So therefore, this can't be 1 because of one of these ones. This can't be 1 because of one of these ones. Where is the 1 in box 4? It can't be any of these because remember we have to have 1, 2, 3, 7, 8, and 9 on these Dutch whisper lines, and 1 can't be here, so 1 must be here. Which means if 1's here, 9 also has to be here, right, to add up to 10. So this is 1 and 9. This can only be 2 or 3, so this can't be 9. This 2 or 3 is only 4 or more away from 9, not 1. So this has to be 9, which makes this a 1. This is 7 or 8. One of these is a 9. Therefore, this cannot be 9 because, again, you can't have repeats in this killer cage. In addition, we know this is 1, 2, or 3 because it adds up with 7, 8, 9 to add up to 10. And the only digits on a Dutch whisper line that can add up to, that can be 4 or more away from 1, 2, or 3 would be 5 or more, right? Because you take a 1 and you add 4 to it or more, you get 5 or more. But 5 cannot be on this Dutch whisper line specifically because it must add up with another digit to add up to 10. And 5 can only add up with 5 to 10, which would break normal Sudoku rules. So this also has to be 7, 8, or 9, which makes this a 1, 2, or 3. Because now we have a 7, and this can't be 9, because we know one of these two is a 9, so this can't be 9, which makes this can't be 1. We also know in column 4, we have a 7, 8, 9 triplet, which eliminates 7, 8, and 9 the rest of the row. This can't be 7 or 8, or rest of the column. This can't be 7 or 8 because of that triplet, and therefore this can't be 1, 2, or 3, because these two digits must add up to 10. This must add up to 10 with 7, 8, or 9 to add up with 1, 2, or 3. Again, on a Dutch whisper line, next to a 7, 8, or 9, if you take the highest one, which is 9, and you subtract 4 or more from it, you get 5 or less. So this has to be 1 through 5, but again, on these Dutch whisper lines in boxes 2, 4, 6, and 8, we have to have 1, 2, 3, 7, 8, 9 there. So this is 1, 2, or 3, which means this is 7, 8, or 9. We have a 7, 8, 9 triplet in row 8 and column 8, which eliminates 7, 8, and 9 in the rest of the row and column. So this cannot be 7 or 8. So it can't be 1, 8, can't be 2, 7. And it can't be 4, 5 to add up to 9 because of the 4 already in the row. So this has to be 3 and 6. Now we have a 3-6 pair in row 8, which eliminates 3 and 6 in the rest of the row. This can't be 6, so this is 5, which makes this a 6. And the remaining digit in row 8 is a 2. So this is 2, which means this can't be 2, and this can't be 8. Similarly, this can't be 1 or 8 because of the 7, 8, 9 triplet in the column. This can't be 2 or 7 because of the 7, 8, 9 triplet in the column. Also, okay, so this can't be 9 because of this 9. Therefore, where is the 9 in this cage? It has to be here. This is a 9 here, which makes that a 1. This can't be 1 because of the 1 in the row. And therefore, where's the 1 in this cage? It has to be here. This is a 2, 3, 7, 8 pair. We're not sure which. We have a 7, 8, 7, 8 pair in row 4, which eliminates 7 and 8 the rest of the row. We can't have a 9 either here, so this can't be 7, 8, or 9. It has to be 1, 2, or 3, which makes this 7, 8, or 9. The rest of the box is also 4, 5, or 6. This cannot be 1, 8, and it can't be 2, 7 because of the 7, 8, 9 triplet in the column. And also, if we tried to make this 4, 5, that would eliminate 2 of these possibilities for these 2 cells, which would force both of these cells to be 6, which is not allowed in normal Sudoku rules. So this can't be 4 or 5. Therefore, this must be 3 and 6. Well, we have a 2, 3, 2, 3 pair in row 2, which eliminates 2 and 3 in the rest of the row. That makes this a 6, which makes this a 3. This 6 means this can't be 6. So where is the 6 in box 6? It has to be here. We now have a 4, 5, 4, 5 pair in column 1, which eliminates 4 and 5 in the rest of the column. So now the remaining digits are 1 and 2. This can't be 1 because of that 1, so this must be 2, which makes that a 1. This can't be 2, therefore it can't be 2 and 8. It has to be 3 and 7, which forces this to be 2 and 8. This is now 2, this is an 8, which makes that 7, which makes this an 8. This 8 means this has to be a 2 to add up to 10. So this is 2, this is 3, this is 2. This 3 means this can't be 3, so this is 6, this is 3. We have a 1, 9, and a 2, 8 here already, so we need a 3 and 7 here. This again is 4, 5, and 6, but this can't be 6 because of that 6, so this must be a 6 here. We have a 4, 5 pair here. Okay, this cannot be 2, so this can't be 8. Well, we have a 1, 3, 7, 9 quadruplet in box 6, which eliminates 1, 3, 7, and 9 in the rest of the box. Therefore, this can't be 1, 3, or 7, 9. This has to be 2, and this must be 8. Since this is 2, neither of these can be 2. We now have a 1, 3, 1, 3 pair in column 6, which eliminates 1 and 3 in the rest of the column. This can't be 3, so this must be 7, which makes that 3. This can't be 1 or 3, and this can't be 7 anymore. Well, this can't be 1 or 3. Since this is only 1 or 3, it would only be with 7 or 9, but 7's eliminated, so therefore this must be 1, which makes this a 9, which makes that a 3. This 3 means this can't be 3, so this is 1 and 9, which makes this 3 and 7. This 7 means this can't be 7, so it's 3, which makes that 7. This can't be 9 here, or 7, because of the 3 and the 7 there, and the 9 here. So this is 2 or 8, which must be with 2 or 8 to add up to 10. Therefore, this forces this to be 3 and 7 specifically. And the rest, well, okay, we still have the 19 cage here. Okay. This can't be 9. I was going to say the rest can be done through normal Sudoku, but it can't. So this must be a 9 then, because there's no other place for it in the cage. This must be 7. This must be 8. This can't be 2 because of this 2, so this must be 8, which makes that a 2. Okay, let's focus on here. The rest of this column 2 have to be 7, 8, and 9, because we have a 4, 5 pair, and we have 1, 2, 3, and 6. This can't be 8 though, so this must be 7 or 9 here. This can't be 8 here, so this must be 7 or 9, which forces the 8 to be here in column 2. Okay. So this must contain a 7 or 9, but we kind of already knew that, actually. If this is 9, it has to be with 4 and 6 here. But there's no 6 here allowed because of this 6. So this cannot be 9 then, right? Because any other combination doesn't work. So therefore this must be 7 then, which makes this a 9. 7 requires 2 digits adding to 12. Cannot be 3, 9. Can't be 5, 7. It has to be 4 and 8. So this is 4 and this is 8. And now the rest we probably can do with normal Sudoku. Let's look at ones. We know where the 1 is in box 5 because these are eliminated by that. This one eliminates these ones. These cells are eliminated by this one, so it has to be here. And now we have 8 1s, so that we know where the last one has to be. It has to be here. What about 2s? 2s are similar. We eliminate 2 from here and here because of the 2s in those rows. We eliminate 2 from here and here because of the 2s in the column. Therefore, the 2 must be here. We have 8 2s now. We know where the last 2 has to be. It has to be here. What about 3s? We have 8 3s. We know where the last 3 has to be. It has to be here. That's 3 in the corner. We celebrate because we know we're getting close. 4s, we don't have many, so let's skip that. Probably let's skip to 9s. 9s, we should have a decent amount. Right. So 9 can't be here, here, or here. It has to be, wait. Yeah, it can't be here, here, or here. It has to be here. And then, because of that, 9 can't be here. In box 1, it has to be here. We have 8 and 9s now. We know where the last one is. It has to be here. What about 8s? 8s is similar. 8s can't be here, here, or here. It has to be here. And we have 8 8s now, so we know where the last one has to be. It has to be here. 7s. In box 7, we know where it has to be. Can't be here, so it must be here. And we have 8 7s now, which means we know where the last one is. It has to be here. Okay, that's 7s. And now about 6s. 6s can't be here or here. It has to be here. 6s can't be here, so it must be here. And then 6s can't be here. It must be here. So the rest are 4s and 5s. Actually, no, we're missing a 6 because we have 8 6s. So now we know this one's the last one. This has to be a 5, which forces this to be 4, which forces this to be 5, which makes that a 4, which makes, not that, this one a 5, which makes that a 4. This 4 also makes this a 5. This 5 means this has to be a 4, which makes that a 5, which makes that a 4, 5, 4. This 4 means this has to be 5, 4, and 5. And that's how you solve it. Yeah, pretty straightforward. I'm actually not sure why we have a Dutch whisper line here. Maybe it's just to make sure that this is a fire ant. Like, because this is, you could use the exact same rule, and it would just end with German whispers, and it's exactly the same. I guess maybe it's to make it orange, so that you have a fire ant-like being, because you have the legs essentially being the orange, with the cages being the head and the thorax. I don't know. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.